time, there was a family of mathematicians who gathered to share their ideas and thoughts about the four basic concepts of mathematics and discuss what are these all about. And their objective was to be able to execute or solve mathematical operations using mathematical expressions, basic concepts, and logic precisely and accurately. And they had come up with the theme of their discussion as the precise, concise, and powerful mathematical language. And they agreed to give a title of this gathering as to understand mathematics is to know its language and symbols. And now, let's hear them and know some relevant topics about mathematics. The first one is what we call set, or a collection of well-defined objects that contains no duplicates. The objects in the set are called the elements of the set. We use braces and capital letters to describe a set. Here are some examples. If you have noticed in our examples, the first letter was capital letter, and at the example in numbers 2 and 3, we can see that there are 3 dots in enumerating the elements of the set. These 3 dots are called ellipses. It indicates that a pattern was continuous. We also have a finite set that contains elements that can be counted and terminates at certain natural numbers. Otherwise, it is called infinite set. For example, set A is equals to, opening parentheses, 2, 4, 6, 8, 10. Even if the order of elements are listed as like this, still it can be considered as the same of the set like this, because the order is not relevant. We call a set as an empty set or null set which has no members at all, but a set with only one member is called a singleton or a singleton set. To specify a set, we need to use the following ways. First is the list notation / roster method, which means listing all its numbers. We list the names of elements by separating them by commas and enclose them in braces. Take a look at these examples. The next way is the predicate notation / rule method / set builder notation. It states a property of the elements. Example, the set of all x such that x is a natural number and is less than 8. Last is recursive rules. It is a way that defines a set of rules which generates or defines its members. For example, now I will explain to you the different types of set. First, we have equal set, or two sets are equal if they contain the same elements. Examples are like this. The next one is equivalent sets, or two sets are equivalent if they contain the same number of elements. For example, which of the following sets are equivalent, given these examples of elements? All given sets are equivalent. Why? Even if no two of them are equal, notice that all sets are with the equal number of elements, which is 3 numbers. Another type is universal set. It contains all the elements considered in a particular situation and denoted by U. Example letter A. Suppose we list the digits only. Then U is equals to, opening parentheses, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and closing parentheses. Since U includes all the digits. Another example is, suppose we consider the whole numbers, then U is equals to, opening parentheses, 0, comma 1, comma 2, comma 3, and closing parentheses, since U contains all the whole numbers.
Good morning, everyone. Today I will discuss the another types of set. Subset of set. A subset is a set whose elements are all members of another set. For example, set A, 1, 2, 3, 4, 5, and set B as 1, 2, 3, set C as 2 and 8. So, try to look this symbol of subset of set. The answer is B as a subset of A. Proper subset is a subset that is not equal to the original set, otherwise improper subset. For example, given 3, 5, 7, then the proper subset are 5, 7, 3, 5. Cardinality of set is the numbers of element in a set. For example, find the cardinality of each set below. Number 1, set of M. A, B, C, D, and A. So, the cardinality of M is equal to 5 because we have only 5 elements. Power set, the collection of all subset of set A, is called the power set of A. It is denoted by power of set. In power of set, and every element is a set. For example, we have 2 elements. Set of A is the P and Q. So, this will be the symbol of power of set. Operation and set contains the element found in set A and set B, or both. In symbols, A union B, or X such that X is in A or B, or both, or is the conjunction. Example, there are universal set composed of all whole numbers. Example, union, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Next, we have set B, contains a perfect where the 1, 4, 9, 16, 25, and 36, and also we have set A, 19, and 18. Intersection of set. The intersection of set A and B, written A and B, is the set containing the elements that are both A and B. So intersection elements, they have a common element. So example, A is set of 1, 3, 5, 7, and 9, and B, 2, 3, 5, 7, and 11. So the common elements are 3, 5, 7. Complement of set. The complement of set is written A is the set of element in universal set that are not in A. So, wala siya sa set A, pero nasa sa universal set. For example, universal 1, 2, 3, 4, 5, 5. So, set universal A is 2, 4, and B, 2, 3, 4, C, 1, 2, 3, 4, 5, and D is empty set.
Good day everyone, I'm Florin Luigi Mabok. So for today, I will discuss about relation. What is relation? It is a rule that pairs each element in one set. It is a set of ordered pairs and or X and Y. What is ordered pair? Ordered pair is the composition of the X coordinate and Y coordinate, having two values written in a fixed order within parentheses. So let us use X and Y as our domain and range. X is our domain and Y is our range. So the X coordinate is always comes first, followed by the Y coordinate. As we can see in the definition of relation, it is a set of ordered pairs. So it is a set of ordered pairs. So in one set, they are ordered pairs inside. So example, this is the example of relation. 1, negative 1, 1, 2, 1, 3, and 2, 3. So this is the example of relation because in one set we have ordered pairs or ordered numbers inside the set. So another example of relation. 2, negative 5, 8, 39, and 15, 39, 20, 39. So now, we will use table of values. So since as we write, every linear equation is a relationship of X and Y values, we can create a table of values. This is the table of values. That's all. Thank you.
He told me that the life of my dreams would be promised and someday be mine. He told me that my power would grow like the grapes that thrive on a vine. Hi, I'm Isabella, and today I'll be discussing about the definition of functions in mathematics and how to identify it. But first, let us recall what is the previous topic, which is relation. So what is relation? Relation is a set of ordered pairs like this: negative 6 and 2, 6 and 4, and 3 and 5. These numbers are called relation. It is because it is being paired in a parenthesis. So now let's proceed to function. Function is a relation in which each input X has only one output Y. So what is input X and output Y? Input X is a set of all first coordinate. In this given examples, negative 6, 6, and 3 are the first coordinate or the X. It is because it is the first number in the given set of ordered pairs. On the other hand, 2, 4, and 5 is the Y or output. It is because it is the second number in the given set of ordered pairs. Here's a trivia. All functions are relation, but not all relation are functions. Now, I'll give you an example of a relation but not considered as function. 5 and 8, 3 and 4, and 5 and 10. This is relation. It is because it is a set of ordered pairs. But it is not a function. It is because the first number or X, which is 5, is repeated.
Hey guys, my name is Joseph Fabiano and today I will show you how to solve binary operation. But first, let's just define what is binary operation with a song. Binary operation on a set is calculation, two elements of the set to produce another element of the set. When you math binary operation. Binary operation using the symbol asterisk is defined to be A star B equals 3A plus B. wherein B are real numbers. We use symbols to represent by an operation instead of function names. Yes, we do it with addition. We use symbols to represent by an operation instead of function names. Multiplication and integer. But how to solve binary operation? Given a binary definition, if we had A star B equaled A plus B plus 3, where A and B are real numbers, we've got to find the identity element E. So what I want you to remember then is that we do A combined with B, I would expect to get back. So I'm going to substitute this definition here and solve the equation. But remember, I also need to show that it works the other as well. I combined with A. So first of all, then working off this A combined with E, replacing the B with E, we therefore have A plus E plus 3 will equal the value A, and just subtracting A from both sides and subtracting 3 from both sides leaves us with E equaling minus 3. So do remember, then we need to check to see whether it works the other way around, and we get the same result, that is E combined with A should equal A. So in this example, all we need to do is replace the E here with the E. We do that, we therefore have E plus A plus 3 equals the A, and again solving for A here, we see that E equals negative 3, so that confirms then that therefore the identity element is E equals minus 3. And I hope guys were able to get that.
Good day, I'm Rika Maingusan and I'm going to report about elementary logic. So, logic is the basis of mathematical statements and arguments. Its basic rules are essential to understand mathematical statements. So, what is proposition? If a proposition is true, then its truth value is true, which is denoted by capital T. Otherwise, its truth value is false and is denoted by capital F. Example, determine whether each of the following statements is a proposition or not. If a proposition, give its truth value. Proposition P. Mindanao is an island in the Philippines. So this statement or sentence is example of declarative sentence, and it is P is a true proposition. Why? Because Mindanao is an island of the Philippines. Number 2, proposition Q. Find a number which divides your age. Q. This is not a proposition. Why? Because this statement is an example of imperative sentence. Therefore, it's not a proposition. And in conjunction, if both P and Q are true, then the truth value of the compound statement P and Q is true. When the two propositions are true, so the value is truth. If there is false, then the truth value is false. So here's the truth table. We have the P, the Q, and the conditional or the truth value of the P and Q. So T and T, so the truth value is true. Second, T and F, so the truth value of second is false. Third, we have the F and T, so false. The fourth is F and F, so false. So next, the disconjunction V or in disconjunction of any of the propositions is true, then the truth value of the compound proposition is true.